Okay, so I'm going to start. Uh, Let me share my screen. Okay, are you able to get this screen, guys? And in this screen, you have done lots of things like loss functions, errors, some absolute errors, square error, why we are choosing the square error over the absolute error, and also we are talking about some error function. It is called the loss function also. We have already seen these things in the previous classes. We have convert this equation to the function in A and B, where A and B are the parameter of your equation. Okay, and at the end when you calculating the total error value or loss function or loss value, you have seen that this function is converted in the form of function of A and B. Okay, so and you see that after ignoring this B, this function looks like this. This is supposed to be a parabola, but it doesn't mean that every time you will get an equation of parabola for the error or the loss function or the cost function. This function could be anything. Your function, your this function could be looks like this. But for better understanding, we are dealing with this parabola. Okay, and in this class 2, we are discussing on this equation. Okay. In the last class, you have seen I am going to revise this the previous classes in 5 to 10 minutes. That you will be understand every point clearly. What was happening uh, in the last class. Okay. So let's start from what from here. Let me check this. Okay. From beginning, you have seen that okay, okay. Thank you. Let me choose my white color. In this very beginning, you have understand this graph that in the normal way, what will happen? What is happening? You have done that when you have like some input or some like value, and you have some program. Program could be anything. That by using this input and output you will get but input and program you will get the output. Very simple. Suppose a input is like x and program is like checking the event and x is equal to 7, so it is returning as either true or false. But in the machine learning, what is happening? You don't have any program. Machine learning can generate the output without writing explicit program. So what, how this possible? So it is using some example of inputs and outputs. By this using this input and output, you will get a program. Program is here nothing. Program is relation between of input and output. Suppose input is x and output is y. So there is program is nothing. There is a, y is a function of x. Function of x. This function looks anytime this function your y of f x looks could be anything like ax square plus bx plus c. It could be like ax plus bx or maybe b. It could be like 1 raised to the power e minus ax plus b. This function could be looks like anything. This function could be looks like anything. This is depend on the what we are going to predict. Okay, so this equation is nothing, guys. This equation is, you can say that this equation is a model. Okay, this equation is a model. So here, before getting the program, you have decided your function looks like, how your function looks like. If you going with this is called the linear function, this is called the quadratic function, this is called the exponential function. So you can follow this anyway. So how we can understand which model suitable for this input output. Okay, this is the question, because you have to identify which model will be fit for this type of solution. Okay, we will discuss these things in the later in this class too. But suppose you are going with this model ax plus b. Okay, this is your model where x is a variable term and a and b are the constant value. Okay, so here y is ax plus b. This ax plus b is nothing, this is a function of x. Okay, and here a and b are the constant, but what is happening? But a and b are constant. Means suppose this is your input and output. Suppose there is an input like x and y. Here x is equal to 3 and y is equal to 5. This is like 7. This is like 13. This is like 10, like 19, and so on. Okay, means it is a meaning that when you choosing this model, it is meaning what? This function validate this equation. Here you see y is equal to ax plus b. Okay, if you follow this equation for this data, so how a and b we are going to decide? So this function validate this value, and this value. So suppose if you go with this value 5, if you putting 5 here and ax plus b, and b, x is nothing, x is 3. So 5 is equal to 3a plus b. 3a plus b. So here you see a is equal to 1 and b is equal to minus 1 will validate this equation. So at the final your equation looks like this: a minus x 2x, this is a 2 now, 2x minus 1. So when you finding this value a and b, your equation is completed. You can put any value of x, you can and you predict the y. And in the past class I have already explained this: input output will generate the program after choosing the model. Program is y is equal to ax plus b, and model is y is equal to, program is 2x minus 1, because you have a data set like this. Okay, now you have a program come with a new input and you will generate the output. You will generate the output. So suppose you have coming with like 6. The output is 2 into 6 minus 1, like 11. So this is the way that you have to predict the output. But question is, this data looks very stable, but in the real world data don't looks like this. Data don't looks like this. Data looks like that way. In the place of 3, there may be like 3.5, and it is like 6.9, and it's 8.1. This is the real data. And if you choosing the real data, this function is difficult to validate. This function is difficult to validate. And suppose you follow this data as a graph, So data is looks like this. Their data is not in a linear format. So you will do what? You will try to find, you will find a line or equation which pass through all the point, because this point is not validated this. So maybe it is not able to pass the line. So I will pass any line and you will get some error value. This error value should be minimum for best line, for best equation. That's why we are moving to this equation, total error. Okay, and this equation looks like what? Because your y is your final value and equation written ax plus b, and because we are choosing the square error, because we have to neglect the negativity, and also because we are going to be check minimum or maximum thing, so we are going to be differentiate one more time. So that's why we are going to square. Okay, if you go into this square and this value is like a fixed value, this fixed, and this is the parameter, because we are going to predict this, and your equation of E is looks like PA square plus PB square QB square some m. This is the equation looks like, and this equation, I think this is the equation of some this, and this is your error. Okay, and this error should be minimum. Error should be minimum. Find the value of A and B where E should be minimum, and this E should be minimum means your line, you are getting the best line, you are getting the best program. So we are going to this way. This is the equation. We are trying to find the minimum error for this equation, and this is the value of A and B. When you find the value of A and B, this is your output, and you will get the final equation. So guys, are you understanding what is happening? Yes or no? Hello? Guys, till this point I revised just my previous class. You are getting some confusion in any point? You can tell me. Hello? Okay, so I need to see your chat. Perfect. Now come. The next is how to get the value of A and B. Okay. Now, this is the equation of, for understanding I am ignoring ignoring B, and this is your. So, okay. So here, okay, this is your A and this is your E. Now, how we get the value? We are not like that directly differentiate and try to re-differentiate again for getting the maximum minimum value. We are not doing with this way. We are follow gradient descent algorithm. Gradient descent algorithm. This is a very simple algorithm. Algorithms. Okay, now how the gradient descent algorithm looks like? The gradient descent algorithm will choose a random value of A or B, maybe some random value. Okay, suppose you are choosing the random value of A and B here. Suppose only A, ignoring the B, and after that they will calculate the E, and again it will change the value of A and B again in some with some value. Means first what they will be predict the value of A and B randomly, and then we are getting and we are changing some value, to A to delta A, changing some positive and negative value. Okay, they are changing some value. Suppose this value, a small change, minor change, and your A will be updated, and then you will check with this A. If you are decreasing, if your E value is decreasing, it's good. You are changing again. Again, you are updating the value of A. Okay, and after certain number of time, maybe you will get your error, minimum error, and that time your value will be funded. Means from random value you will get a some value of A, maybe B also, where your error is very less or minimum, and that time you will get the final value of A and B, and your equation is completed. But guys, in the real scenario, not everything is looks so optimal. In the real project, what is happening? Not every time, not every time you will get this value. Okay, there are two reasons. First, suppose you are changing. Okay, suppose your changing is too small or too high, then maybe it will take multiple steps. Means every time you are going from this way to this way, you are taking a step. Suppose you are using a for loop in a programming language. It will take a step every time. And suppose you are taking 1,000 steps, and after taking 1,000 steps, you will still here. And it is not good idea to be trained or checking the step for millions of times for some data set. So it is very difficult to how should we change the value of delta I. Suppose your changing is too high, so maybe you will directly jump from here and then here, sorry, and there, and maybe there and there. So it is also not good. So guys, we are passing on one more value here. It's called alpha, and it is a learning rate. Okay, this learning rate, this learning rate is of some value like. Generally, it is between the 0.1 to 0.5. Okay, but nowadays the lots of very high level of library are there like TensorFlow or PyTorch. They are controlling this value. Okay, for better use. But if you are writing the code from scratch, maybe I will using this value 0.5 or 0.3, and they will get a better result. This is the one method that every time you are not getting this value. Second is what? Not every time it is a good to jump in this position. Minimum. Suppose you are going to create a machine learning model, and guys, you are here and you are decreasing the value. Maybe after the 100 steps, taking the 100 steps, you will hear only, suppose, or maybe in the 52 step you will hear, and you want to check for the 100 step. Suppose you are 0 step and you want to check for the 100 step, and After the taking the 52 step, you are here and you see that your error is already so less and your model giving the better result, means 96% time they are providing the right answer. So you will decide, oh, you don't need to check further, 96% is good result and we are not going to check, we can stop it here. Okay, so he see that your target goal is not getting here, your target goal is you're getting the better accuracy. So we are going to be taking the step, and this step is called epochs. This step is called epochs. Okay, when you going to train your model and you're writing the some Python code, you will have decided how many epoch you have to choose. Sometimes 10 epoch is enough, sometimes 100 epoch is enough, sometimes 1000 epoch is not enough. So according to your model, according to your data set, you have to be understand which type of epochs or which length of epochs are good for getting the better result. Okay, so we will discuss everything in the Python code, that how the epochs is validated. Okay, so this is the way that you have to get the value of A and B, and this is a gradient descent algorithm is working. Only you have to choose some random value, update the value of A. Now the question is, what is the meaning of delta A here? What is the meaning of delta A? So you going to be every using the for loop. Why am I just every for loop you will going to be 100 step maybe. This is your epochs. By default is set to be, anyone is typing something? By default you set some random value A and B. Random value. This is a gradient descent group. And every time you will be updated the value of delta A with alpha sum. Okay, this is the output. And every time you're getting the A, you will predict the output and you check the accuracy. And you see the accuracy is good, or maybe the A value, final E value is decreasing, you are changing again and again for the handle step. This is the way that you have to be given. This is a gradient descent algorithm work. Now, what am I doing? Okay, now. So what is delta A? Because what is delta A? Suppose this is your equation and this is your, sorry, why my cursor is not working properly? Oh. This is your equation. Okay, and you know this is summation from I0 to how many data set are there. So you know this should be the minimum. So you are going to be differentiate D. First let me complete this. Okay, okay, and you are going to differentiate of D, because there is A and B are parameter here, parameterized value. So you are going to be differentiate the partial derivative. So first with dA. So I am ignoring the all the summation. I am only choosing the, suppose there is only one data set value are there. So by dA, and you will get, and you are going to compare with the 0, because dA, this value should be 0 for the minimum, so you are going to choose the 0 value, and you will, after that you will get uh, sorry, means after calculating you will get the value of dA, and you are supposed to be dA is equal to delta A. Okay, this is the way that you have to get the value of delta A. I am going to be derive this equation for higher complex algorithm, because this equation is so simple. Maybe in the next time I will explain this equation for the different thing. Okay, so I will come again to this equation in maybe the later classes or this classes too, where I am going to explain how to get dA and delta B. Okay, don't worry about it. And this is the way that you have to train your model. But your confusion is here, sir. Okay, everything is perfect, I am understanding everything, how to get the DA and everything. Problem is here, problem is here, how we decide the model, how decide the model. So maybe this is the same problem faced by the student like you. Every time I'm telling you, you have to decide the model. So maybe you are confused here that how we change, how we select the model. If this is the confusion, please let me know. I will explain it in very briefly. Why I am choosing only y is equal to ax plus b, not this value. Is this the question arises in your mind? Hello? Tell me. Yes or no? Or there is any confusion in different topics, you can share with me. I will help. Guys, please let me know that you are facing this problem or not. Sir, why you choosing ax plus b, not this equation, not another equation? How you decide the model? Everyone is clear on this point? Hello? I am audible? Hello, hello, hello. Guys, I am not able to understand what is happening in your side. Uh, this point are confusing, or you are, means if this question should be arising in your mind. If this question is not arising in your mind, so it's not a good thing. Okay, now the question is how we decide the model. How we decide the model. So now, for understanding this, you have to understand the types of machine learning. Types of machine learning. Basically, there are two types of machine learning is possible. One is supervised machine learning. Second one is unsupervised machine learning. In supervised, what's the how the things looks like. In the supervised, you have a task to, you have an input and output are given, You have to create a model or, or equation or program by using this input and output where we get some relation. Means there is an input is possible, there is an output is possible, and you have to make an equation to predict it. But in the unsupervised, there is no output is here. Only the input data is available, and you have to create a model which can be cluster the data or associate the data. Okay, so guys, we are not dealing this unsupervised part in this course, and even 90% project are creating with supervised machine learning. Okay, and we are discussing these things in supervised part. Okay, every type of project you are seeing in the LinkedIn or YouTube, everything is under the supervised learning. Means there is no label is possible, there is no output is possible in the unsupervised. Sometimes by using the unsupervised learning, you have to convert a data set from this input to this format, and again you are shifted to the supervised machine learning part to generate an equation. Okay, this is the final goal. Okay, so directly we are learning in supervised machine learning part and dealing with this. In supervised machine learning, there are again two part. One is called classification, and second one is regression. Anyone in this classroom who are able to explain what is the meaning of classification and what is the meaning of regression? Anyone? Hello? Anyone in this classroom who are able to explain what is the meaning of classification, what is the meaning of regression? कोई तो कुछ बोलो. It is good, but could you explain briefly? In regression, output is continuous. In regression means check the output after overload. Okay, let's explain this. Okay, classification. Yes, it is good. It is helping me to classify the data, and regression is helping me to getting some continuous value. So how is possible? Listen. So suppose at the end your target is by using this input, you have to predict the output. Okay, now suppose you are going to create a model or train the model where the model is predict the price of the what? Laptop. Price of the laptop. So suppose you are putting the value, of RAM and processor, and you will get the price. Okay. Suppose RAM is 2 GB and processor is i3. Your price is like 32K. His RAM is 3 GB and processor is again i3. Price is 6K. RAM is 4 GB and processor is i5. 43.5K. Some value are there. And suppose RAM is 8 GB and this is i7 is like 91K. Suppose. So here you see that your price is not fixed. Your price could be anything according to the input. So means your price could be anything, means you are getting some regressive value or continuous value. So suppose you have a input and output are like this way. So that time you have to enter the regression supervised machine learning algorithm, machine learning model. But let's see what is happening. Suppose you have a information of a student like IQ level and the study time like in R, and they are able to pass the examination or fail the examination like result. Suppose IQ is between the 1 to 10, their IQ is 9 and it is reading 8 hours, so they will pass the exam. And 6 IQ and they are studying for 4 hours, it is also pass the exam. Sorry, pass the exam. IQ is 7 and they study 2 hours. Sorry. Just 1 second. Okay, now. Okay. Now see, you pass the exam. Now IQ is 7, they are studying for 2 hours, they fail the exam. Now IQ is like 9, 1 hour exam, fail the exam. Means you see, this is your input and this is your output. Output is only two types is possible. One is pass, one is fail. One is pass and one is fail. Here you see the output is fixed. Either you pass or fail. When your output is fixed or some distinct output is possible, then you are under the classification machine learning algorithms, classification supervised machine learning. So you have to see before checking, before creating the model, before jumping to in this graph, before jumping to the equation part, you have to decide the model and you have to see that which type of model we are going to predict. It is model good for the classification or it is good for the regression. Okay, so according to the data set, you have to decide which type of model you are going to create. It is classification or regression. Okay, so now I am going to take an example of classification or regression. Suppose there is a data set, okay, there's some x value and there's some x2 value, this is some input. Yes, Selja. So I am going to use x1 and x2 and this is y. Okay, so there's some point, there's some x1 value, x2 value. Here you see this is your x1, this is your x2. Now in this case, some x1 is like 3 or 5 and this is like green, 9 7. This is your rate. Okay, so guys, you see this type of data is here, and you are going to be predict the value of green and R. So here is two fixed value. Then according to the data set, you are decided, oh, this is the ML model, classification machine learning model. This model should be classification machine learning model. So we are going to be create the function of x. This should be written two value. This should be written only two value. So let's understand. Suppose you are choosing this equation, this linear equation. Guys, tell me, by using this equation, you have to predict only two what? Green or red. Because this is an equation and this is just some character, so I will convert into this value to 0 or 1. There is any confusion to understand why I am putting 0 or 1? When the output is 0, it is supposed to be 0, it is supposed to be green, and when the output is 1, it is supposed to be red. So now come, this is a linear equation. If you plotting this value like some input x and this is y, and if you plotting this graph, it looks somehow is like that. Okay, please listen carefully, very important. And guys, according to this data set, there is only two outputs possible, either 0 or 1. So this is your output is either 0 or 1. Whatever your x value, your value is either 0 or 1. But if you follow this model, like this, if your value is x is this, you will get the value of this. If your value is like 100, maybe your value y value is, according to this graph, is 99. Okay, but is 99 is not a good value to deciding the output. Your value should be either 0 or 1, either 0 or 1. So if you follow this equation as a model, linear equation, this model is not good fit for this type of data set. Yes, this data is good for what? This data is good for regressive data set. Suppose if you follow this equation for this data set, where x is this and y is this, where x is some like information of the property of land, like, and this is a price like 500 acre, this price is 9 lakh rupees, 600 acre, this price is 11 lakh rupees. So your data looks like this. Okay, where the linear equation is good for this input, this is the y value, for this input this is the y value, it is good, you can go with this equation. But for the classification, something like that, you cannot follow this equation to getting the right accuracy and right model. So guys, are you understanding what I am talking here? Bolo, please tell me. Are you able to understand what is happening in this point? Okay, good. So it is, you understand that this equation ax plus b is good for what? For regression. But we cannot able to use this for the classification. Himanshu, Selja and Akanksha, are you able to understand this thing? Why I am telling this is not, it is good for the classification but not good for the regression. Okay. Now, now we have a model. Now we have a model for linear equation, or now a model for the regression. But I want to see any model which is suitable for the classification. Now I am going to explain it here. Now one model. So in this classroom, in this workshop, I will dealing with multiple models. First model is called linear regression. This linear regression, guys, is good for regressive data. And second, I am going to discuss one more model, which is called logistic regression. Logistic regression. Okay. This logistic regression has a regression suffix, but this model is used for the classification. How? I will explain it here. This is the regression. This regression, linear regression is nothing. There is equation model looks like this. Okay, I will become again in this equation where when I am talking about the data set. We are discussing about the data set. I will talking about this again. Now classification. Classification is the logic regression function is looks like y is suppose is a function of x and this function is looks like this. E this exponential. Okay. If you plot this diagram, if you plot this diagram, this linear regression diagram, this diagram graph just looks like this. Okay, you change the value of x, you will get the value of y. But if you're talking about this graph is looks like this. Okay, this is your x, this is your y. Okay, this is your x and this is your y, and y is 1, x is 0, and your graph is looks like this. Okay, for any value of x, your value should be either 0 or 1, but not exactly 0 or 1. Okay, this graph. Suppose for this value here, your value is 0.6. For this value is 0.4. For this value 0.5. For this value 0.9. Means you are getting the value. You are getting the value not 0 or 1, but between the 0 or 1. Okay, 0 to 1. Suppose after passing some value, your value is getting 0.8. 0.8 means you are getting the value of 0.8. It is a meaning that 80% chances that this is the pass. This person is passed the examination, and suppose you are getting the value of 0.3 means 30% chances this student is passed the exam. So I will convert it to 0.3 to 0 and 0.8 to 1. We are not getting exactly the right output, but this is a percentage output. Okay. So by using the probability distribution, you will getting the value either 0 or 1. Okay. So and this way, this model is going to be used for the classification. So guys, I hope you understand till this point everything is clear. Hello. Anyone is confused in any point? Himanshu, Akanksha, Sailja, and Garima, another student who is here. Akanksha, Arjit, Ayush, anyone? Kevin, Mathi, Manish. Everyone's clear to this point? Logistic regression is a model and classification is a task. Okay? Garima. If the model between y having constant bound, the logistic regression. I'm not understanding, Salja, your question. Could you please explain it?
So if the value y is bounded and that is also in continuous form, not the discrete
Yeah, it
value.
looks like continuous
But
one.
y value is bounded, then we can say it is a
Yes, right. So, guys, you are understanding everything till this point. I hope this is a very like I try my best to explain the machine learning very difficult topic so clearly. I hope you are understanding till this point everything. Everyone clear now? I hope you enjoy this lesson till this point. So, in the next class, we are going to use Python to explain, to write everything which is written in the theoretical part. But one thing I am going to discuss which is very important is the data set and something like that. So, suppose you are here to use a linear equation using the ax plus b. So, how the a and b looks like and how the axis looks like. So now in the real world, the data set is looks like this: x1, x2, x3, and xn, and there is a y1. So this is your x, and this is your y. So sorry, x2 1 1 1 1, x1 2, second data set, second 2, and so on and so on. So this is your input. For this input, this is your output. Okay. So you will get the output. Here you when you choosing the x, it is not a single value, guys. It is your this vector. Okay. So the equation is exactly looks like a1 x1 a2 x2 a3 x3 and b. But where b equation should be looks like this. So this equation is going to be a1 a2 a3 and up to this is a vector and means just one second. Just one second, I will explain it everything. Please cooperate. So it is meaning this a is nothing, a is a vector. I will explain a vector as scalar this later. Where a is a1, a2, a3 and up to. And x is nothing. X is x1, x2, x3, x4. Okay. And your y is nothing. Your y is a x plus b vector. And here you want to be multiply, this is a vector and this is a vector, so you have to be not able to multiply these two vector, you have to transpose this, and now your equation is in the reality is looks like this. And when you multiply this vector, you are getting a1 x1 a2 x2 a3 x3 and so on. Are you able to understand this, guys? This point? You can use your mic too. So tomorrow when you are writing, not tomorrow, in the next class is happening on the like when आपकी नेक्स्ट क्लास कब होगी? ट्यूसडे को. Okay, if you didn't transpose Salja, you cannot multiply in the vector multiplication. I will explain it. आप इनको multiply नहीं कर सकते. In the linear algebra, if you want to get this type of value, you have to multiply this vector like n cross 1 and 1 cross n. Then you can be multiply as a dot product. I will explain it. Don't worry. When I am writing the Python code, I will explain it again. Yes, n should be common. Otherwise, multiplication is not possible. The dimension should be same. Okay. Salja, this point is clear. Himanshu, everyone. Don't worry. I will be again come to this point in like when I am writing the code. So now, come to this point. I will be using some word here. Okay. So here you see, this is the data set. So this X is called, input, but in the machine learning, it is popular as a features. This is called a feature. This is Y is the output, but in the machine learning, is popular word is come label or target. So next time I am using features and target or label. When I am talking about target and label, means you are going to pass about the output, and when you are talking about feature, means the input. Okay, this is a feature, this is a label. This thing is going to be discussed. So I guess theoretical part is completed. In the next class, let me close my